If you're studying physics, you've probably been told that the area under a velocity versus time graph is the displacement. But why? To prove this, let's look at an initial, a more simpler graph. In this graph, the object is going at a constant velocity because this is flat. And we know that no matter what velocity the object is going or how, we know that the average velocity times the time is equal to the displacement. And if this is v1 and it's going until t1, we know that the displacement of an object that went through this is v1 times t1. But that's the area of this rectangle. This is a rectangle because we know that this is flat because the velocity is constant. Because you can think of this side being t1 and this side being v1. So the area of this rectangle is v1 t1, which is also the displacement. And even if we jump up like this here to t2, then, and this is v2, then we still know that this is delta x1 or v1 t1, and from the time interval t1 to t2, the object goes at a displacement of v2 times t2 minus t1 because we want the change in time. So now we know that the area under a straight velocity graph is the displacement. But most of the time, our graph isn't this simple. It might look like this, for example. Now what do we do? Well, this can actually still be composed of rectangles. Like this. Like this. We know that the area under the rectangles is the displacement, but the graph we want isn't this staircase-like thing. We want this smooth graph. Now what do we do? Well, as the width of these rectangles approaches 0 and we get more and more rectangles, this approximation of the area of the rectangles actually becomes exactly equal to the area under the graph. Let me say that again. The area of the rectangles is exactly equal to the area under the graph as the width of these rectangles approaches 0. And since we know that the area of the rectangles is the displacement, then we know that the displacement is also the area under the curve, or the area under the curve is the displacement. And if the graph goes below 0, for example, we just consider this time interval, the displacement during this time interval, to be negative.